जान दो बच्चे,
दिख नहीं मिल रहा है।
क्योंकि तुमने 3 मिनट पहले चालू कर लिया ना।
इसमें म्यूट कैसे होता है?
इससे ये जो है ना, अभी ये वाले बटन, इससे थोड़ा वीडियो बंद हो जाता है ऊपर वाले से।
इससे वीडियो बंद होता है और इससे
उससे म्यूट होता है।
नहीं होता। तुम ज्वाइन करो देखो, क्योंकि 2-3 क्यों है फिर यहाँ पे? एक ग्लोबल प्रीव्यू
वो छोड़ दो, प्रीव्यू नहीं, दो चल रहा है ना ये दोनों। अच्छा फिर ये चल रहा है, ये देखो ये ऊपर नीचे हो रहा है ना, ये इससे।
हाँ तो यही बंद होगा ना।
वो नहीं, उसके बाद मत करो अभी,
देखो तो एक बार।
तो हिलने की आवाज भी आ रही।
इतनी तेज? अभी मैं म्यूट करके देखूं एक बार। ओके तो म्यूट कर सकते हैं मतलब। तो चालू कर दिया है ना। एवरी साउंड यू कैन हियर।
7 लोग ज्वाइन करें, बोलो।
Okay, cool. Hey everyone. Okay, so last exam, right? Physics, and then we are done. Say hi to me in the chat so I can see that you are all here. Okay, so yeah, Sophia is here, Scarlett is here. Okay, so what we are looking at first is the main part, which is practicals. They are very important, right? So we will briefly go over each practical because you will see some questions from there, from the practicals coming up, right? So we'll start with the first practical, which is about this particular practical. I'm not very sure whether you've revised on it or not, but it comes quite a lot in the exam about extension. So can just somebody tell me what the idea of this practical is? What is this practical about, where you have a spring, a ruler, and then you put some mass on the ruler? Tell me in the chat what is the practical about in the chat. Guys, you can't just tell me. You just have to consistently respond to my questions so that you are not losing your focus, and you can just enjoy after tomorrow. It's just one last exam. Okay, so yeah, it is, Sophia, about spring constant K, but there is a to see how force affect. Yes, correct, Scarlett. It's about how force affect the extension of a spring. And if you see the spring, which I have shown you here, it's a simple idea. Like, you might it'll click in your head very quickly once I explain. So just I'm going to talk about some high demand part here as well, which is going to be like a grade 8 or 9 stuff on this practical. Okay, so let's listen very carefully. You will be given a spring and they will ask you how force equals, so there is a formula, force equals mass times acceleration. sorry, force equals K times E. Now this force, and there is another force which acts downwards. There are two forces acting on the spring when you have an object or a mass on it. Tell me, what is the second force that acts on the spring? Let's see how many of you know this. So yeah, just answer my question. What is the second force that acts on the spring, on the mass of the spring, if you attach some mass on it? What is that force called which pulls the mass downwards? Come on. Which pulls the mass downwards? Gravity, Scarlett, gravity. Okay, gravity is not a force, but we can say weight. Okay, please remember, weight is a force, and that is what pulling the spring downward. No, Grace. No. So listen to me first. Yeah, this practical, you need to investigate how. Question says how the extension of the spring changes with the applied force. Okay, now remember, you know that it will be extended, right? That is our prediction. But the force that you are having on the spring is equal to weight, which can be calculated using mass times gravity or gravitational field strength. Okay, that is the key, right? And this weight, now please do not forget, weight is not the unit for weight. Okay, if weight is a force, what is the unit of it? Type in the chat again. Come on. Think. What's the unit for weight? It's a force. Newtons. Very good. So weight is measured in newtons, right? And the mass, this is the basic difference between weight and mass, that it is measured in kilogram. And if you times the massive gravitational field strength, you get the weight. Okay, and what they say, how much is this spring is extended each time when you put mass on it and it is pulled downwards. Okay, there is earth that is pulling the spring in the downward direction. Okay, and that is what force is, right? So there's just the unit for gravity, just in case if you get a question on writing the unit for gravitational field strength. Can somebody type in the chat what is the unit for gravity is? Newton per, come on everyone, kilogram. Newton per kilogram is the, Newton per kg. Okay, how do you find the extension in the spring if you have been given these two pictures? How do you find the extension in the spring? What do you do to find this extension in the spring? E, this is what extension is, or no, you just simply, did you understand my question? Very good, Scarlett. You just take the original length, which was 5 centimeter, and extended length, and you do just subtract the new length from the extended length. So you will get 7 minus 5 equals 2 centimeter extension. Okay, type me in the chat again. What is the unit for what is the unit of length in the chat? Should it be okay to have centimeter, or do we need any conversion? Type in the chat again. Yeah, very good. We need every single length, whether it is a wavelength, whether it is extension, whether it is any kind of length, like literally any kind of. People feel like, oh, a spring is very small, extension is very small, so it should be centimeter. No. The standard unit is meter, so you need a conversion. So you do just divide by 100 to work it out in meters. 0.02 meters will be the extension. Okay, very good. Now, then simply, if they ask you to write a method, you simply say weight. What is happening here in this graph? Tell me, anyone? what is happening to the extension as you're increasing the mass or the force? Type in the chat. It's just a description of the, sorry, I'm just going to make it slightly lower so you can see. Yeah, describe. Can you describe this graph quickly, everyone? Come on, come on, come on. Directly proportional. Well done, Deeppreet Kaur. Yeah, it is directly proportional, meaning what is happening? Okay, there are two properties of directly proportional relationship which you can have a question on as well. That the line of best width should go from the origin. Okay, the minute you see the line of best width is going through the origin, that means it's a directly proportional relationship. Okay, and another thing, look at the board. Look at the board. Okay, every time, how much is the mass increasing? Type in the chat again. Every time, how much is the force or mass? Well, I will just say weight increasing. Every time, very good, 100 Newton, well done. And how much is the extension every time increasing as you go the downwards? Come on, by 2. Very good, Grace. So this is called directly proportional relationship. So each 100 Newton increase of force increases the length by 2 centimeter, meaning directly proportional. Okay, they can ask you in the exam, explain your answer. If you said, oh, the relationship is directly proportional, and they say explain your answer, what you would say? Simply, every 100 Newton increases the wavelength by 2 meter, which is what directly proportional means. Well done. Okay, and you will see the graph drawn like this. But I think, and it's just we call it in the chat. Please write down, what is Hooke's law? You might have heard the word Hooke's law. Hooke's law is, anybody? Force is directly proportional to extension, meaning that sign that you see, meaning directly proportional. That's it. Yeah, very good, Grace. Force equals K times E, where K is the spring constant. That's what Hooke's law is. Very good. Well done, Dee. Well done, Branyu. I don't know. I can't pronounce your name, but yeah, that is correct. Now, another thing that you must know is this practical, just use correct units. Start the graph from the origin. Limit of, does anybody know what is limit of proportionality before I move on? Does anybody know what is limit of proportionality? If before I move on, something happens around this line that you see. What happens when it reaches to maximum extension? Yeah, where the objects become deformed. Very good. And do not go back to its original. Yeah, it plateaus. So the point at which the graph plateaus is the point where the limit of proportionality reaches. And is extension still directly proportional to force, or is it no more directly proportional to force? Quickly in the chat. Come on, come on, come on. Is it still directly proportional to force, or is it not anymore directly proportional to force? No. Well done, guys. Okay. Help me with one more thing. You can have a 1 mark question on this. Okay. You can have a 1 mark question on this. Tell me, what are the two forces that are acting on this mass? Very quickly, yeah. What two forces are acting on this mass? Come on, let me see how many of you know this. Come on, come on, come on, come on. There are two forces acting. What are they? One is correct. It is weight. Do not say gravity. You will lose the mark. It is weight downwards. Okay. And there is one more which is acting upward by the spring. What is that force called? Come on. You know it. Starting with T, E, N. Come on, come on, come on, come on. T, E, N. something which is very good, Scarlett. It is tension due to the spring. Okay, that is also a force. Yes, Sophia, and it acts upward, upward on the spring, on the mass. Okay, don't feel like my own students who I teach. They feel like, oh, miss, because the mass is going downwards or the weight is pulling it down, so tension should be downward as well. But it is wrong. Spring pulls things upward. You are pulling it down, but it is actually pulling the thing upward. That is, so tension is in upward direction. Okay, very good, well done. So which force, can you tell me the formula for tension? Does anybody remember? The force due to elastic, F equals K times E. Okay, what is the weight equals to? Mass times acceleration. These two formula, please remember. Okay, can I ask you one stretch question and see how many of you can answer it? And the question is, if, and listen carefully, yeah, my question is, if the two, am I still audible? Okay, yeah. If the two forces are, sorry, if the object is stationary, this mass is not moving anymore. What is happening to force? Are they still, one is increasing, one is decreasing, both force, tension and weight, or are they both equal if the mass is stationary? Newton's first law. Come on. If the mass on the spring does not move, yeah, okay, so then what happens to the two forces acting on the object, upward and downward? Are they changing or are they equal? Come on. Yes, Sophia, well done. Both the forces, Newton's first law, if something is stationary, it must be having resultant force equals 0, and both the forces W is equal to T, tension. Well done. Okay, that's all about. So what questions you can have high demand? One is on this part where you need to know that there are two forces which are equal and opposite. Okay. Another key thing that you need to remember is the extension is calculated by minusing the two different lengths, final and initial. And the second thing you need to remember is this: if the object is stationary, there are two forces acting, tension and weight. And the other thing is to convert centimeters to meters. Okay, fair enough. There is another practical, which is this one, the trolley practical, light gate one. This is about Newton's second law. Is there anyone who knows the formula of Newton's second law? Force equals, force equals, Newton's second law, force equals, come on, you know it. Force equals mass times acceleration. Correct. And this is what the setup is used. Yeah, correct, Grace. Scarlett, correct. This is the setup we use to investigate this, and you need to change one and investigate the other quantity. Just remember, if you know the formula, right, and you need to just check, guys, listen carefully to me, yeah, you will be changing one thing. For example, if you want to change the force, change it, and you can measure the force. I will say just measure it. What is my independent and dependent variable if this is the case? Type in the chat, I'm waiting. Come on. Yeah, what is, no, I want to change the force and I want to measure the acceleration in the trolley. Yeah, very good. So acceleration that we are measuring is my dependent variable. Very good, Scarlett. And the change of the change is my independent variable. Remember, whatever is the remaining thing inside the formula, that will be the control variable. A very important thing to remember. So you need to control the mass. Okay, tell me, what if I am hanging the mass on the string, which force is going to be this? Will it be tension or will it be weight that pulls the thing down? Will it be tension or the what will it be? The weight. Very good. Weight is pulling the things down, so you change the weight, but you have to keep the mass same of the entire system from here to here. Can you see my yellow thing that I have highlighted? This is the system. You must keep the mass same. Okay, so what is going to happen is, Grace, that you will use the mass from the trolley top and place it onto the string there to change the weight. Does it make sense? And you're not, in this way the mass will be constant, because the yellow system that I have highlighted, that's the whole system, and you don't want to change the mass because that's your control variable, remember? Perfect. So therefore this is how we control the mass, or make it just so we are not messing up with the practical. Okay, now what is the purpose of the light gate? Please type in the chat again. I'm going to highlight with a different color. What is the purpose of this light gate? In the chat, please. What is the purpose of the light gate? What does it measure? Grace, it was not, the light gate measures not the speed. Okay, Sophia, tell me what you are measuring. Light gate measures what? What is your control variable? Oh, dependent variable. Time? No. Okay, data logger or light gate connected with the data logger measures the acceleration directly. Okay, they can also give you, they can also, Scarlett, ask you to work out the acceleration using v minus u over t. Okay, this formula will be given to you on the formula sheet. Okay, so that is all about this practical, but I'm just going to show you the, guys, are you out of 10? How much will you give yourself for this understanding of this practical? I want to tell you one more or few more couple of things. If you're not sure about it, type in the chat quickly. Out of 10, how much do you understand this practical? 8, 6. Okay, fine. So is this making sense? How you keep the system's mass of the system, Sophia? Do you understand this part? That mass of the system, you can keep it same by keeping the mass on the trolley. Say yes or no, that it makes sense. Okay. Listen, guys. Now what can happen? Okay, Sophia. Now what can happen? You can have another variation to this practical, Scarlett, where, listen. Now listen carefully. In this practical, you were measuring the mass. Look at the board. How do you change the force, Scarlett? You just have to, the force that you're changing is the weight, right? And what you simply do, Scarlett, is you bring the masses which are on the trolley on to the bottom part like this, and you keep increasing that. And if you increase the mass, and weight equals, the formula for weight equals what times what? Weight equals mass times gravitational field strength. So if you're increasing the mass on the string, it will automatically increase the weight. Very good. Yeah. Do you understand this now, Scarlett? Okay. Once you get this part, okay, this is a bit tricky part. You will have to keep your focus here to understand it. Otherwise, it will not make sense. There is a second variation to this practical. listen carefully, yeah? Second variation. They can ask you, listen carefully, you're still measuring the acceleration, but this time you do not change the force, but you change the mass. You change the mass. How do we change the mass? What should I do to change the mass? Type me in the chat. How can you increase the mass on this, on the separate, what will you do? Come on, add more. Where do you want to add it, Grace? On the string? This time, add more what? Where do you add it? On the string or on the trolley? No, Sahib. Sahib, listen, Safiya. Yeah, very good, Grace. Not on the string. Because now I have changed the practical and they can ask you to do that. You have to see, if this is what I'm changing, the mass has to be put on the trolley one by one, not on the string. Can somebody tell me why? My question is, why should I not put masses on the trolley if I want to investigate the change of mass and acceleration? What it will do? It's difficult, I know. Yeah, very good, Scarlett. Because the string is going to give you the change in weight, and weight is force. But you need to control that. This is another practical you're doing now. Very good. So you put the mass on the trolley, not on the string, if they ask you this practical. At the bottom of this this sheet, I have written here, and I will send you all these sheets once the lesson is finished, and you can see how these two investigation can be done. Okay, you can investigate by investigate the effect of mass, and you can investigate the effect of force, which is weight. Give me thumbs up. You understand this, guys? Okay. Now, one more thing. They can. You might have seen questions where they increase the height of the trolley. I'm gonna rub this off everything so you understand. Yeah. Okay. Now listen. There could be one more variation to this practical where they put the trolley on a, they increase the height. They increase the height from here and put the trolley on this, what do you call it? The slant thing? What do you call it? The something. Tell me in the chat, what do you call when you put the trolley on something like this? Ram. Very good, Sophia. So you can put the trolley on the ram. Yeah. And they can say, investigate the acceleration. How do you work out the acceleration? If you put the trolley on a ram and you change the height of the ram, then what will be my independent variable? IV. What will be my IV? What will be my dependent variable? Come on, tell me. And they want you to investigate how changing the height of the ram affects the acceleration of the trolley. Tell me what is my independent dependent variable this time? Guys, can you not just stare at me? Type the answer. Yeah, very good. Will it be dependent or independent? Because I'm changing. Investigation is to investigate the acceleration in trolley at different heights of the ramp. Very good, Grace. Now you got it. So the height of the ramp is going to be your independent variable because that is what you are changing. And dependent is what you measure, which is acceleration. Okay. How many light gates do I want? Okay, tell me. To calculate acceleration, listen carefully. Yeah? To calculate acceleration, the formula is v minus u over t equals a. Type in the chats how. Yeah, very good, Scarlett. You will need two light gate, one here and one here. And so this, which one out of v and u is the initial velocity? Type in the chat again. Saif, thank you. Which one is the initial velocity? Is it v or is it u? In the chat again. What is my initial velocity? V or u? U is initial. Very good. INITIAL, initial. And V is the final velocity. Okay, very good, guys. So what you simply do, the first light gate will give you the initial velocity. The second light gate will give you the final velocity. And you just use that, and it will give you the time as well. And you can work out the acceleration, the light gate. Okay, and that's another variation you can have on this required practical. Here we go. Do you remember doing this practical, like the sound waves? No, not sound waves, I mean waves practical. There are 3 variations to this practical. Give yourself out of 10 to your understanding, so I know what I need to pitch the lesson on. Out of 10, how much do you know about these practicals? Okay, so fine. So let's go over it quickly, yeah? Okay, I'm gonna use my black screen just to explain to you what we are looking at. So this practical is about, I'm gonna use my different color pen. This practical is about, let me know if you want me to change the ink of my pen, because it could be brighter for some people. Okay, so the practical is about the sound waves. Oh, no, sorry, the waves. Waves. And what you need to know is 3 method. Number 1, number 2, number 3. Number 1 is measuring the speed of the wave. So you will be investigating the speed of the wave in 3 different medium. And the speed, I'm going to write speed of the wave in solids, so solid, liquid, which is water, and third one, which is gas, which is sound. So liquid is ripple tank, and gas is just the sound wave. Okay, just the sound wave. And solid is the string practical. The speed, how many formulas do you remember of the speed? Type in the chat again. How many formulas of wave speed do you remember? Speed equals, come on. Speed equals, very good. One is the normal one, distance over time. What is the other formula of wave speed? Sahib. What is the other formula of wave speed? Come on, you know it. Frequency times lambda. Lambda is the wavelength. Wavelength. Okay? And F is the frequency. F is frequency. There are only 2 formulas you need to know, guys. Yeah? So one, I'm going to highlight it with a different color pen. Distance over time. One is Scarlett, frequency times wavelength. 2 formulas. Okay? And this practical could be for solid, liquid, or gas. So you need a string, a ripple tank, and a sound wave. Here we go. This is your first one, ripple tank practical. Okay? Tell me, how do you do this? What do you at all, if anything you know, please tell me, what do you know about this practical? Come on, ripple tank. Anything. Yeah, the formula of Scarlett that we use to measure these waves is what you correctly said. Frequency equals, no, wave speed equals, yeah, very good, Sahib. Wave speed equals V equals frequency times wavelength. How do you define frequency? Somebody define frequency, please. Frequency equals number of waves. Number of waves. Yeah, definitely. Waves per second. Well done. Per second. So this per second means in 1 second. If you don't know this, in 1 second, how many waves are passing? Very good, Grace. Now to use that, so basically you use this setup. There is a screen at the bottom. There is a signal generator you see here, and there is, I'm just going to highlight signal generator, and there is a black screen at the white screen at the bottom. What happens is that you shadow the light and the waves, look at the board, yeah? Look at the board. The waves, simply what you do is you put a, again I'm going to use a different color pen, a timer here, a timer. This is my timer. Yeah. And you let the, there is a dipper which goes up and down. Type in the chat. If the dipper goes up and down, what it will do with the waves, water waves? Will it create any waves, or will it not create any waves? What will happen? Yeah, Sahib, very good. The vibrator vibrate and creates wave. And the waves are very fast. You have the water waves like this, and they are very, very fast, right? So yeah, ripples will be created. So if you want to count the number of waves, type in the chat. In 1 second, is it possible or is it difficult? Just say possible or difficult in the chat. Shall I repeat my question? If you want to count the number of waves per second through a point, is it possible? This is the point I want to find. Point, number of waves. Is it possible or difficult? Very good. It is difficult, right? So what should we do? Somebody already said in the top part. What should we do if you can't find the waves in 1 second? What should you do? Come on, use a technology and use a video to record it along with the timer. So this timer, what you will simply do, I'm going to highlight it with a different color, write it here. You simply put, let's say 10 seconds, you film it, not take a picture, just film it. If you just record it, record, 10 seconds you record, and then after 10 seconds, stop the camera and see in slow motion from this point in 10 seconds, how many waves has passed through. So I'm going to show you here. So how many waves have passed through this point in 1 second? No, in 10 seconds. So let's say in 10 seconds, you in the slow motion, you saw that there were 90 waves. How do you work out the waves in 1 second? Type in the chat again. So again, I'm repeating. In 10 seconds on the timer, in a slow motion, you saw 90 waves passing through it. In 1 second, what will you do to find? Come on, it's a simple maths. Sahib, is it 90 divided by 1 or 90 divided by 10? Yes, very good. So 90 over 10, this is equals to 9. What is the unit for frequency? Come on. Do not stare. Write the answer. Unit for frequency starting with H. Hertz. Hertz, very good. Here, hertz is the frequency for the hertz is is the unit for frequency. What do you do to find out the wavelength? From here, if you want to find the wavelength, what do you do? Just to let you know, before you even answer my question, I'm going to show you something. See, the reflection, can you see this reflection coming on the screen at the bottom? The crust is the dark part. So every crust make a dark line on the screen. Crust, and simply, what is a wavelength? Somebody can define wavelength to me. Wavelength is the distance between two what? Two, come on, you know it. I know you know it. Very good. Two sahib, two consecutive. You have to use the word consecutive, one after the other. No, Grace. Wavelength is the distance between two consecutive. Consecutive means just one after the other. Consecutive crust. Okay, so like this, number 1, number 2, number 1, number 2. That's my two consecutive crust, and the length between them is my wavelength. Okay, so what should I do? It's very difficult to find that little path. So what should I do if I know the length of the entire screen, which is, let's say, 20 centimeter? What should I do? Basically, it's very difficult to find the length between two dark lines. What should I do? Anybody? Shall I tell you? No, Grace, listen what we do. What we do is simply, now can I have you all to focus now, because this part is important. So you count the number of waves. 1, 2, 3, 4, 5, 6, 7. 7 dark line. Yeah, Scarlett. And you divide that by, so 20 divided by 7 dark lines. That gives you one length of one wave. Very good, Scarlett. That's correct. So 20 divided by 7 in the chat again. 20 divided by 7 in the chat again. Come on, that's the wavelength. Okay, what is the unit for wavelength, guys? Should the wavelength 2.9? Yeah, okay. So 2.9 centimeter. What do I need to do? Should I keep it centimeter? No, you can use both of them. Scarlet is in the white line. You can either use the white or the black, doesn't matter. They are true. The white lines are true. Yeah, very good. You need to convert centimeters to meter for sure. Otherwise, you will lose the mark. Okay, very good, Grace. So that's all about the crust, the ripple tank practical. Sound waves. The second is the sound wave. Can somebody tell me how can I find, which formula should I use to measure the speed of sound? In the chat again. What formula should I use to figure out the speed by looking at this picture, the speed of sound wave? Yeah, it is. Yeah, very good. Distance over time. So this time we will use distance over time. That will give me my wave speed. If the distance is 100 meters, is it okay? The person shouts, the sound goes and then comes back to the person, and he starts the timer and stops it. How much distance should I take? 100 meters, 400 meters, 300 meters, or 200 meters? In the chat again. Come on. Yeah, very good. 200 meters. Why? Why, Grace? Why, Sahib? Type in the chat. Why 200 meters? Why, Scarlett? Scully, it's not 100 because the wave will go, look at the board, the wave will go this way and comes back to the person. So 2 times. Very good. And we call it echo. Have you heard the word echo? Echo means when it hits and comes back. Yeah, very good. And then you just put distance over time and you work out the answer. Okay, and that's the formula you use. String 1, have you seen this one before? Say yes or no in the chat. No, Grace, you didn't see? No? Okay, this one, Sahib, is not very frequently asked, but it is required for you to know as well. So this is a signal generator. Can you see signal generator? So you just put some kind of, it is a kind of vibrator. Please listen carefully. It's a kind of vibrator here that makes the string go up and down and make a wave like this. Okay, and that's what all of this is about. You can read the signal generator for frequency. So it will give you the frequency, let's say 20 hertz. It will be written on the screen. And you need wavelength because wave speed equals frequency times wavelength. So to get the wavelength, you can you see, look at the board everyone? Can you tell me how many half waves do you see? Half waves. How many half waves do you see in the chat, please? How many half waves do you see in the chat, please? Come on, half waves. You're listening. Yes, Sophia. 6. So if I have distance from here to here as, let's say, 50 centimeter, tell me how much is the half wave would be. If you have 6 half waves, how much is the length of the one half wave if that is 50 centimeter length over there? Answer in the chat, please. Come on. 50 divided by 6. Very good. 8.33. Well done, guys. Those who are working using calculator, well done. 8.33. If I want to know the length of the full wave, what should I do with the 8.33? Come on, come on, come on, come on. What should I do in the chat, please? What should I do with 8.33 if I want to have times? No, full wave. One full wave is this. See, Sophia, this much. Can you see? Tell me, if this is the one full wave, what will you do to get, if you got the value of one half wave, what will you times it by? 6 or 2 to get one full wave? Yeah, very good. No, Sophia. Sophia, look at the board. See, this is, can you see? I'm going to highlight it. One half wave, crest, and one throw. You only need 2 half waves to get one full length. Do you understand? So you times it by Grace 2. Am I making sense, Grace? Can you please type in the chat, please? You understand? Okay. Okay, fine. Now there's a Leslie cube that comes up quite a lot. I don't know whether you are familiar with Leslie cube. Type in the chat yes or no. No? Okay. Very important. Like they ask, this has been asked quite a lot as well. But I will explain maybe it will make sense. So basically what happens, what is the concept here is that you have different surfaces. If I give you a surface which is white in color, okay, or a cube which is white in color, and if I give you a cube which is, this is gray in color, and I'm going to draw the absolute white color cube, because on my screen otherwise you will not be able to see. So you have a white color, and I just want a color which is absolutely white. Okay, can't find any. Okay, so I will just use this. Can you see the difference in the color of the boxes? Yes? See the difference? This is my white color, and that's my black color. Okay, Grace, now listen, yeah. This is dark color cube, dark, and this is white color, white. Okay, and the rule is, which is the most important part, if you can remember for tomorrow, hopefully this will help you. The rule is a best absorber of radiation is also a best emitter. Best, emitter, emitter. A best absorber is also a best emitter. Okay. Now listen, guys, listen. In this box, like a cube, you put hot water, and you put hot water. How is the water? Hot. Water, hot, like 100 degrees Celsius. 100 degrees Celsius. Water. Okay, now type in the chat for me. Who is going to emit the most radiation? A dark colored object or the light color object? No, it's not scarlet, it's not insulation. Who is going to emit the most radiation? The dark color object or the light color object? Only Scarlet answered my question. Grace, did you say dark? Is there anyone else who knows it? Okay. Okay, fine. So what, yeah, Grace, listen. So what you simply do, if you put a thermometer, if I show you thermometer 10 centimeter away, this is my thermometer, let's say. What is it? The thermometer. Thermometer. 10 centimeter away. Okay? And there is another thermometer this side, and this is also 10 centimeter away. This is thermometer as well. Oh, sorry. Tell me which thermometer will increase the temperature most. Thermometer with the dark object or the thermometer with the light or white screen? No, I mean white object, a white cube. Type in the chat. Whose temperature with the dark? Why is dark? Why is dark? Why is the dark will increase the temperature most? Nobody knows it? A best absorber is a best emitter, and we know dark objects are best absorber, so they will also emit most radiation. Yeah, very good. And the radiation, I'm going to show you radiation, goes to the thermometer out there, and thermometer senses the radiation, a lot of radiation from the dark object. However, the light object, he is a poor absorber and poor emitter. Only one radiation going down there. In the dark one, there are two radiation. In the white one, there is one radiation. So the thermometer near dark one increases the temperature more. Okay? Okay? Very good. Well done, guys. Okay, so that is all about this practical. But they will give you different surfaces. You see, matte black. Type in the chat, what surfaces can you see? Matte white, shiny metal, and a dull metal. Yeah, very good. I think you understand this, guys. Yeah, you understand this practical, Leslie Q. I will send you these. You can see the sheets and it will make sense because you understood the concept. There is reflection and refraction practical as well. Okay, Type in the chat about reflection and refraction. How much do you know about these practical? Are they okay? You know them? Or not sure? Huh? Oh my god. Reflection. Guys, this is very simple, right? So you normally don't have practical on reflection. Draw a straight line this side. You can see the method here. You have a mirror which reflects the light. Draw a straight line on the paper. Place a plain mirror. Draw a normal line in the center. Shine a ray at the mirror. Mark an incident and reflected ray. Repeat using and just plot a graph. Do you understand what is happening, guys? So basically, do you or shall I explain it with the drawing? Please type in the chat. Yeah. Okay. So what is happening is simply you, this practical is, okay, look at the board here. Look at the board. What you simply do is this. You have got this, a mirror here, mirror, plain mirror, yeah? And this is the incident ray. And what happens is that when you put a light, look at the board, everyone. Look at the board, everyone. Yeah. When you incident a light here, right, that hits the mirror and this light reflects back. We call it reflected ray. You need to have a dotted line, dot line, that normal. This is an imaginary line that you see normal. We call it imaginary. IMAGI, imaginary line. It's not existing. You just have to draw it 90-degree to the mirror. Okay. What you will find is this. What is this I called? What is this R called? At least write that in the chat. Type in the chat. What does I called and what does R called? Yeah. Not refracted, Grace. It is reflected. This is reflection. So this is your incident, angle of incident, and this is angle of reflection. Can you see the spellings? Reflection, LEC, not RAC. No. Okay. Yeah, fair enough. So then this is just literally what is the rule is that angle of incidence, if it is equals to 40-degree, what you will find is that angle of reflection is also equals to 40-degree. They never changes. That's it. Angle of incident is equal to angle of reflection. Okay, they never changes. Refraction can come up. Yes, Grace. Done. This is the last practical. We just have to quickly go over Newton's laws and we are sorted. Give me 1 second, guys. Yeah, okay. So what I was saying, just one more thing, guys, which is about refraction. Refraction, and then I will teach you Newton's laws, and then I will let you go. Okay. Yeah. after the practicals, if I have enough time, I can help you with that. But yeah, just quickly, refraction. Refraction is when you, so basically, reflection is mirror and refraction is two different mediums. So you have a dense medium, and you have a rarer means less dense medium. Rarer, they normally write rarer, rarer medium. Okay, and they just different, like they draw a line and you just have to, for example, this could be glass, this could be this could be a glass. Okay, a glass, and this could be air and glass. Okay, now what happens is this: you need first of all a normal ray, and if there is a, I'm just gonna change, see if this is making sense. Yeah guys, look at the board. If you've got this bulb here, like a bulb, and there is a light coming out of the bulb, that light comes, or ray comes and hit the glass, so it is going from the bulb to the glass hitting, and it, because it is going into a denser medium, what will happen to it? Tell me in the chat. Will it go close to the normal or away from the normal? Close to the normal or away from the normal? Type in the chat. It is going, yeah, it will go close to the normal and it will tilt like this. Yeah, correct. And there will be one, it's not only one time refraction taking place. You understand what is happening, guys? Yeah. So you have this is your angle of incidence, this is your angle of refraction, R. Not reflection, refraction. Okay, fine. And that's it. I mean, this is angle of refraction, this is angle of incidence, and you are sorted. There is second reflection will occur when it goes from out from glass to the air again. Tell me what will happen with the ray now. Will it go close to the normal or away from the normal? Close to the normal or away from the normal this time? Type in the chat. No, the ray is now coming, very good rays. It will go away from the normal like this. Okay, so that's all your refraction is. So if you know the basics, that will be great. Let's talk about Newton's laws quickly. Newton's laws. Tell me what happens, the first law. Talk to me about the resultant force. What happens in the first law? Come on, at least. You need resultant force equals 0, first law. This is my first. Okay. Resultant force is equal to 0, Scarlett. When, Grace, the object is, there are two conditions for resultant force equals 0. Please tell me in the chat if you remember. The object must be, come on. Oh my god, nobody knows it. Stationary or, come on, no. Constant, very good. Constant velocity, not speed. There is a difference between velocity and speed. I hope you know this. Tell me the difference between velocity and speed in the chat again. Come on, quickly. What's the difference between speed and velocity? Come on, guys. Very good. Yeah. So the velocity is a vector. VV. Okay. Fair enough. So now the resultant force is equal to 0 if the object is stationary or moving at a constant velocity. Help me with this, yeah? Object a car, forward direction force is 200 Newton, backward is 100 Newton. Is this object stationary, constant velocity, or accelerating? Type in the chat. Do not sit and stare at the screen. The object is having two forces, a car. Very good. Yes, very good, guys. It is accelerating. Why? Is the resultant force RF equals 0? Yeah, Grace, correct. Is the resultant force 0 or not 0? Type in the chat again. Is the resultant force 0 or not 0? No, it's not equals to 0. So, first law of Newton, first law is not applicable. So, therefore, there will be a resultant force on it. Resultant force of second law. This is your second law. Second, Newton's second law says, guys, that resultant force is not equal to 0. Then object will what? Come on. Something starting with A, C. Come on. The object is accelerating. Well done. The object is accelerating. Correct, Sophia. The object is accelerating if the resultant force is not equal to 0. Okay, fine. That's one thing. Newton's third law. So acceleration means, somebody tell me, what does acceleration mean? Is changing direction acceleration or not acceleration? Is changing direction acceleration or not an acceleration? Very good, Grace. Very good. Yeah. Changing direction is acceleration. Yeah. Very good. Surya, changing direction is acceleration. Changing speed is acceleration. Slowing down, speeding up, all of that comes in acceleration, and resultant force will not be equal to 0. Well done. Okay. What about the Newton's third law? Tell me third law. Let me see how many of you do remember third law. Very commonly asked, and it's, I don't know how many of you are able to apply when a force acts on an, there is an equal and opposite reaction. No, Scarlett. Okay, here we go. Listen guys, listen carefully, yeah? For third law, you need rule number 1, 2 objects. Rule number 1, 2 objects are needed. Okay, right. If now I will draw 2 people here, right? This is my object 1 and this is my object person, like person 2, and they both are exerting force on each other with their hands. Okay, these are 2 people. Do we have 2 objects? Yes, we have object 1, object 2, or person 1, person 2. Right. So what I'm saying, now listen carefully, yeah? When a force, no, Scarlett, listen. Object 1 or person 1 exert a force on person B of 20 Newton. Okay, person 2. Write in the chat, what did I say? What did person 1 do to person 2? Type in the chat. Come on, I said it 3 times. Okay, here we go. Object, very good. Object Grace, object 1, I'm going to write it down here. Object 1 exerts a force of 20 Newton on object 2. This will give you 1 mark. 2 objects are needed. This statement gives you 2nd mark. Then what happens? Is that it? Is that the end of the story? What will object 2 do to object 1? Come on. Object 2 will also, yeah, but you will not get the mark for saying same exerts same force. You'll have to say no. Hold on, listen. This has to be word to word exactly what I'm writing on the board. Otherwise, you will not get the mark. 2 objects. Object 1 exerts a force of 20 Newton on object 2. You will have to say, therefore, object 2 also exert equal and opposite force on object what? Type in the chat. Object 2 also exert equal and opposite force on object what? Type in the chat. In the chat. 1. Well done. Okay. Now please do not use those when a force acts. There is an equal and opposite reaction. No way. You have to stick to the simple 3 statements I said. What you can do is that just check the question. Yeah, guys, just check the question. The objects could be anything. You have to take the name of those objects. You can't just write this as it is. You have to name the 2 objects you are considering in the answer to get 3 marks. This will be a grade 8/9 question. Okay, look at the question, see what 2 objects are, mention them in the answer, and write the statement as it is. Sorted. Okay, say yes in the chat, you understood it. Say yes in the chat, you understood it. Okay, now we're going to talk about the motor effects, and then I would allow you to leave because I think sorry, loudspeaker. We don't have time that much, guys. Okay. Choose one, loudspeaker or motor. Okay, let's go over motor and we'll see. Okay, for motor effect, it's a very, very simple part. You just need to know a couple of four things for motor effect to gain the full marks on it, and just memorize this mark scheme. I would rather say just memorize it. Motor effect. Okay, now what happens in motor effect is this. You have 2 different magnets. You have a north pole and a south pole. Okay, and there is a loop of wire which is passing across through the 2 motors, through the 2 magnets, and it just sits there, and there is a connection of the battery around in the motor. Okay, right. So what will the wire has in it? Like, if the battery is connected, means what does the wire have? Type in the chat. Wire has what? What does the wire have in it? Come on. The wire has what? Current. Yes. In which direction the current goes? Negative to positive or positive to negative? In what direction the current flows? Come on, don't tell me that you don't know this. Direction of the current. Come on. Yes, it is positive to negative. So you go from positive to negative like this. Okay. How is the magnetic field in the permanent magnet? How is the magnetic field north to south or south to north? Suri, come on, answer, everyone. The magnetic field goes from north to south. Always north to south. Okay, very good. And what happens is this. Now, they can give you a 4-mark question, guys, yeah? And you just have to use these key terminologies. First of all, you need to put a split ring commutator. I don't know whether you know this or not. How is the battery current is? Like, the battery gives out a alternating current or the battery gives out a direct current? Anybody knows? Battery gives out a... Come on. Battery gives out a... Starting with D, I. Very good. It gives direct current. Okay. But if you want to spin the wire round and round in the motor, do you need a direct current or do you need alternating current? What is your guess? You want to spin the wire round and round and round. You want alternating current or direct current? Yeah, correct. We want not the direct current, but alternating current. Okay. Now, what makes the current alternating? You connected battery. What will make the current alternating and how? Anybody guess? Starting with S. P. Very good. Split ring commutator. Alternating current is achieved by split ring commutator. This is one marking point where they ask you what does a split ring commutator do, and you just have to say this statement. Split ring commutator. Does anybody know who can type in the chat? What does split ring commutator do? Very good. It swaps the contacts, right? You are needing the same key terms. Swap the contacts every half turn. EVERY, every half turn. Okay, you have to say this to gain the mark. Split ring commutator, swap the contact every half turn. At this moment of time, how, why, don't worry, memorize it. Swap the contact every half turn to keep the motor rotating in the same direction or to change the direction of current. You can write anything. Swap the contact every half turn. Why? To change the direction of current. Okay, this is a high demand question. They can ask you like a 2-mark question to explain, but this will be like a 8/9 question. Okay, fair enough. So memorize this, yeah? But what is the concept of the motor? What is happening inside the motor? That could be like 4 marks as well. How do you do that? Tell me. what is happening? Okay, I'm going to asking you a question. Please keep answering, yeah? How many magnetic fields are there in this motor? One magnetic field or two magnetic fields? Again, type in one magnetic field or two magnetic field. How many magnetic fields are there? No, Surya, there are two magnetic fields. No. See, so you'll have to say this. Basic. Oh yeah, you'll have to say it like this. There are two. I'm gonna write it down here. First you understand, then I will write it. Yeah, and there is a magnetic field around the current carrying wire. I'm gonna show you the different color so you can see. Around the wire there is a magnetic field which you cannot see due to the flow of current. You know this, guys, yeah? A magnetic field due to the flow of current in the wire. You know this. Come on, you know this, right? And one magnetic field is due to the permanent magnet, and they both interact. Okay, I'm going to write it down, yeah? Number one, there are two magnetic fields, MF. Okay, now type in the chat as I ask you a question. One from what? One from the permanent magnets, and one from current carrying. Come on, guys. One from permanent magnet, one from current carrying wire. What does these two, not circuit, say the wire, Scarlett. What does these two magnetic fields do? Okay, Evans, what does these two magnetic fields do? So one from the permanent magnet, one from the current carrying wire. What does these two magnetic fields do? Do they do nothing, or do they interact? Come on, do they do nothing or do they interact with each other? Yeah, they interact. Okay, the two magnetic fields are interacting. This is a key wording you will be using, okay? The two magnetic fields are interacting. Tell me in the chat, what will they exert on the loop of wire? It's just like two people fighting, right? One person fight, the other person fight, and whoever is in the middle, which is the wire, what will they do with the wire? Very good. They interact and exert a force on the wire. Well done. On the wire. Okay? Okay. Give me thumbs up that you understand this, guys. And this is what motor effect is. Guys, there is no magic. If you simply, this is like a mark scheme I have put on the board for you. Simply just write this. One, there are two magnetic field, one from the current carrying wire, one from the permanent magnet. They both interact and exert a force on the wire, and therefore the wire spin or starts moving. But then you need to keep the wire moving in one direction like this. Do you know, you might have seen your hair dryer. Have you seen the hair dryer? Yeah. In that hair dryer, this wire is connected with the fan. So your fan, the hair dryer have got a fan. How does that fan move? Do you know that? The fan I have shown you, this is my fan, for example. In the hair dryer, how does that fan go round and round? It is connected with this wire that you see in the motor. The wire itself is going round and round, and the fan is connected with it, so it goes round and round, and that's how motor helps you to move the things. Okay, do you understand the mark scheme, guys? So one marking point here, one marking point here, one marking point here, the split ring commutator one, and what does it do is here, like all the four things for the motor effect. This could be 5 mark answer as well. Okay, so take a screenshot of it. Do you have a question? Can you please type in the chat so I can answer your question quickly? Okay, right. There is a, so basically, okay, fine. Just to let you know, there is a formula to calculate the force, which is force equals on the generator. Albans, generator is the opposite of motor. So you know how simple, only one thing you need to make different change in the generator effect. It's very amazing thing. Generator effect is very good, like it's very nice thing to understand. Give me 1 second. Okay, listen guys. What happens in generator effect quickly, sorry, Ailwins, I'm just gonna answer your question, is that listen carefully, in motor you have a battery, current flows, two magnetic field interact. But in the generator effect, there is no battery. What you simply do, listen carefully, in generator effect, you take two magnets, north and south, and you take a closed loop of wire with no battery in it, and there is a voltmeter. You can just see there is going to be current flowing in it. It is opposite of motor. No battery needed is a major difference. Okay, and you move this wire up and down to cut the magnetic field lines. Move the wire. Okay, now Alvin, tell me in the chat, if there are two magnetic field and you're moving the wire, closed loop of wire, up and down, what will happen in the wire? What will be produced in the wire? There is no battery in it. No, not sure? Current, very good. So simply what you have, you need a closed circuit, not circuit, closed loop of wire, closed wire, and plus movement plus magnetic field, and that gives you current. Do you see my explanation? However, in the motor effect, Alvin's, is totally opposite. What happens in motor effect is this. You need what plus what? Current plus you need current, and you need magnetic field, which is common for both of them, plus a battery. No, current means battery, and magnetic field plus what? Current plus magnetic field gives you movement. Okay, so the wire spins, it started to rotate. That's your motor effect. Am I making sense? Alvins, did you understand what I'm talking about? Closed loop of wire. Okay, fine. I will now, guys, let you go. Is there anyone who needs the sheets of the required practical? There is a cheat sheet as well. If you want, I can just forward it to you. Say yes if you need all of these documents as I normally Okay, that is fine. Grace, other people needs it, so I'm just gonna forward it anyways, so you can have a look through it before tomorrow's exam. And I hope you all do really well tomorrow. And that's tomorrow is the last exam for how many of you? Please type in the chat. I know one exam is still left for some people. My husband is attaching the documents. Just give us a minute. Until then, answer my question. How many of you are still having exam after tomorrow? Yeah, Spanish on Tuesday. I think, yeah, my other students were having, but then you can enjoy the summer, isn't it? You have done a good hard work. Um, wow, Alvin, you're gonna enjoy. Like tomorrow is the last day for you, isn't it? Just put some efforts into tonight and morning when you get up, and then do the good work in tomorrow's exam, and you are going to be sorted and enjoy your summer afterwards. Okay? Um, can you? Yes. We are just sending cheat sheet. Those who need it, just stay with us for 1 more minute. And there is a whole concise form of everything you can see in that. Yes. No, I'm just sending it now. Uh, okay, I'm just attaching it. You can just have it now. Elvin, before you can download it actually. Okay, here we go. I've sent it. You mean to say for what? Oh yeah, of course. Elvin, it is going to be there on. You can watch it later. Okay. Bye everyone. Good luck for tomorrow. Well done, guys. Bye.